All right, so in this video, we can talk about the types of intermolecular forces and how to find them in molecules. Okay, so say that you are given a molecule. Okay, you are given a molecule, right? There are three questions you should ask actually. Okay, so the first question you should ask is this molecule polar or non-polar? Okay, so is it polar? Okay, so if your answer to that question is no, okay, then you got yourself a non-polar molecule. Okay, then you have a non-polar molecule. Okay, if you have a non-polar molecule, only type of intermolecular forces possible is dispersion forces. Okay, D only. Okay, here D stands for dispersion forces. Okay, now if the answer to this question, is it polar, is yes, yes, okay, then you need to okay, then your molecule is polar. Let's write it down. Then you have a polar molecule. Okay, so if you have a polar molecule, then again you have to ask another question. Okay, and the question is, does it have hydrogen covalently bonded to nitrogen, oxygen, or fluorine? Okay, does the molecule have hydrogen covalently bonded to nitrogen, oxygen, or fluorine? Okay, so if the answer to that question is no, okay, then your molecule has dispersion forces, okay, has dispersion forces and dipole forces. So DD stands for dipole forces. Okay, and if the answer to that question, does it have hydrogen covalently bonded to nitrogen, oxygen, or fluorine, is yes, okay, then your molecule has all three types of intermolecular forces: dispersion, dipole, and hydrogen bonding forces. So here HB stands for hydrogen bonding forces. Okay, that's it. So you can follow this key to determine the types of intermolecular forces you have in a given molecule. Okay. Now, with that, I want to mention one other thing. Okay. So when it comes to any molecule, you have dispersion forces. Okay. Okay. You can see that all three scenarios here have dispersion forces. Okay. But when it comes to polar molecules can have dipole forces on top of dispersion forces. Okay, that's what we have here. And on top of that, if our polar molecule has hydrogen covalently bonded to nitrogen, oxygen or fluorine, okay, then it's going to have hydrogen bonding forces on top of dipole and dispersion forces. Okay, so if you have comparable molecules that when I say comparable, I'm talking about the size and the number of electrons in the molecule. Okay, so if the size and the number of electrons are comparable, then the more types of intermolecular forces you have, stronger the overall intermolecular forces. Stronger the overall intermolecular forces, higher the boiling point, higher the melting point, higher the density, higher the viscosity, and lower the vapor pressure and lower the volatility. All right, that's it. So I hope that this helps you summarize the types of intermolecular forces. I'll talk to you. I'll see you guys later in class. Bye, everybody.